As part of setting the pace for the global automakers industry in sustainability and innovation, Rivian, one of America's most recognizable EV manufacturers, envisioned a digital thread to simplify their IT operations and unlock innovation. Leveraging the depth and breadth of the AWS platform, Rivian has reshaped their modern simulation and R&D operations to decrease time to market in the automotive industry. In this session, we're going to hear about how using open source frameworks and the near limitless scale of AWS compute and some other next generation technologies has removed the bottlenecks for engineers and analysts inside Rivian. We'll also talk about how Rivian overcame some obstacles and improved the engineering experience, simultaneously encouraging self-service for the research and development teams. As part of my role at AWS, I manage a portfolio of industrial solutions for engineering and design. In the past 2 years, it's been remarkable the number of AWS customers that have begun to transform the way that they enable innovation. For me, however, Rivian really stands out amongst those success stories for the vision that they brought to remove IT barriers and their team's ability to execute to enable those innovators to spend less time thinking about technology and more time on innovating. It's been exciting to have a front row seat for Rivian's digital transformation journey on AWS. And in just a moment, I'll hand it off to Madhavi to share the story of her team's work to implement an agile environment for simulation and modeling. Later, I'll come back to cover the details of the architecture we implemented together and accommodate the needs of the business. Lastly, Madhavi will share some of the early results and talk about what the next steps are for Rivian. It's my pleasure to have a collaborative partnership and engagement with Madhavi, so I'll go ahead and turn it over to her now.
Thank you, Walker, for that. I'm Madhavi Isanaka, and I lead IT for Rivian as the Chief Information Officer. For those of you who don't know what Rivian does, we are a startup, yet not a startup. We have been in existence for 11 years, and our strategy has evolved in what we bring to the market, but our intent to maximize the impact to the world hasn't changed. It has been the center theme. We are trying to bring vehicles to the market in B2C fashion, adventure vehicles to kind of like inspire active lifestyle, so you can get out to the beach or to the parks and enjoy with your family and friends. But also we are partnering with Amazon to create a sustainable future through Amazon Delivery Vehicle. In the next year, our plan is to bring 3 vehicles to market: a truck, SUV, and a Amazon Delivery Vehicle. I've been at the company for about 14 months now, with the intention of actually bringing the entire IT footprint to life. And we are going to share a story about the journey. The work is so much on the plate, we didn't want it to actually build our own data centers, and we are not in the business of building IT company. We are actually in the business of enabling rest of the company to achieve our business goals. So we have partnered with Amazon to actually use our Amazon services, AWS services as our data center, and we are going to share a snippet of actually one of the successes we had this year. As part of the strategy, we have figured out actually a few ways on how we are going to leverage our Amazon partnership and AWS services. And for the internal, for all internal development processes, when we are picking actually best of the breed commercial software applications, wherever possible, we are actually hosting them on Amazon's AWS services. Also, we are developing our own internal applications. It's not about actually with the intent to migrate them to different clouds. It's the intent to actually go faster by leveraging the footprint and all the services available within AWS. We are creating cloud-native applications on AWS. Other big piece actually in the automotive industry, where we consume a lot of compute in aiding actually our engineers to do real world simulations in a compute environment, to build vehicles and do testing like crash testing, or to do noise vibration testing. It is quite expensive and time consuming, and in the early stages of product development, we won't have enough physical vehicles. So this is an area where we are actually partnering and leveraging AWS to bring compute to life for our engineers. Third big area is actually how we do data and analytics. The data from our vehicles coming into the cloud, data from all our enterprise systems, data from our manufacturing shop floor. How do we bring that actually together and drive insights for right in decisions at the right places in the business is another area. So this is how we are leveraging AWS footprint instead of our own data centers holistically in the IT strategy. Today, I wanted to share with you one of the use cases we have made progress on actually. After 3 months into my role here at Rivian early this year, one of our HPC clusters failed. We have 2 clusters, about 2,000 cores in total, and losing half the capacity when actually our go live of the vehicles releases to market is so close is a big setback. Our engineers and leaders who came from the traditional auto companies were very concerned because to stand up anything new would take approximately 6 months is the mindset they have had. So they were quite worried about it. And at the same time, we had new use cases popping up requiring incremental capacity. So how this is going to be the gating factor for progressing our engineering function closer to allowing us to manufacture the vehicles was a big concern. We partnered with AWS and we actually brought up the compute cluster on the AWS framework, which actually Walker is going to give you a couple more details about the architecture to drive proof of concept. The expectation, the worry was it would take 6 months. We collectively with AWS team thought that actually we could bring it to life in a proof of concept in 6 weeks. But we worked closely together and we had to go find actually resources who understood the simulation software so that we could tune it appropriately. And we had people working from Europe, from Japan, from US, throughout the 24/7 cycle. And in 3 weeks, we were able to prove the possibility in the new ecosystem. That is quite surprising. And at the same time, obviously, in the process, the team had to try all different kinds of instances to see what would appropriately fit the needs for Rivian.
Thanks, Madhavi. So as Madhavi mentioned, with the question around which instance types made the most sense for different workloads answered and the teams achieving performance goals, the focus very quickly became the move from POC to production. So we worked very closely around some of the requirements with those teams, of course, to make performance and usability key factors. The other critical component for Rivian was to make sure that we were leveraging the on-demand nature of AWS and that they're only paying for the services that they're using. We also wanted to make sure that the users didn't need to wait in queues. So this is an obvious benefit for moving these types of workloads to the cloud, is that resources are on demand when they're needed. That means no users need to queue and wait for available resources like was the case on-prem. We also want to make sure that we're enabling some of the different pricing models available with AWS as we're having additional discussions to make sure that we're providing the most cost-optimized environment for Rivian to run their workloads. We also want to make sure that the engineering teams have access and to understand with transparency around the way that they're using AWS resources and using the IT capability that Rivian is deployed for them. So we implement that via analytics. So Rivian and AWS have worked together with a trusted partner, as mentioned, XISS, and with our professional services organization to implement the production environment. We chose to implement an A/B deployment where we could do updates and test out new paradigms to help improve the experience for the engineers, but leave the production environment alone. So we continue to rapidly make updates to that environment in partnership with professional services and Rivian IT teams, and look forward to improving that experience for the engineers as time goes on. After evaluating multiple solutions, Rivian landed its CAE workloads on AWS's scale-out computing solution. This open source framework is developed and used in production by Amazon Devices organization to produce award-winning devices such as the Amazon Echo. It's designed to simplify back-end operations for administrators and lets users focus on value-added research and development activities that enable engineers and designers to focus on innovation and not IT. At its core, the solution implements a scheduler residing in EC2 instance that leverages CloudFormation and Amazon's auto-scaling capabilities to automatically provision the resources necessary to execute user tasks, such as scale-out compute jobs, remote desktop applications as well. The solution also deploys some persistent storage via Amazon's EFS service and FSx for Lustre for scratch storage. On the back end, there's also some analytics capability enabled through Amazon Elasticsearch. And on the front end, also using S3 as a persistent storage base for cluster logs and other persistent data. The tenets for the solution are most users are not familiar with HPC, Linux, or AWS. So we would want to make those users to focus on that code and analysis, and everything else has to be automated. Process automation and convenience are as important as performance, and we want to leverage the existing AWS Web Services ecosystem. Rivian's team interaction with the new HPC implemented many patterns, but some are still in development. As we've been working with Rivian, one of the core requirements was to make sure that teams didn't have dependencies, some of the development teams didn't have dependencies on each other. So in part of that development activity, for instance, as you can see on the left-hand side, the aero team shouldn't have dependencies on the safety team or the durability team unless they were collaborating. So we want to make it as seamless as possible the way that they're executing their simulation and modeling workloads. So what we've implemented using EC2 is, for instance, unlimited storage for the aero team. And here you can see a data set being copied into the EFS file share. Once that user is ready to submit their job, some checks and balances are implemented, automating checks around whether there's available budget, that the user's instance types are the correct instance type for the job, and then of course that there's application licenses available and ready. Once those checks have passed, that user's job moves into the EC2 compute that's created ephemerally just for that job. And then those results are available immediately within the AWS framework to perform things like post-processing and visualization that you see here. And then as this scales up into a larger team framework, multiple members within the team can perform the same types of activities and perform visualization and collaborate on that data set in the shared storage location. Similarly, the safety team has a similar engagement, again, in a separate environment from the aero team. In this case, if a user, for instance, didn't have budget available, they're notified via SES, Amazon SES, that their job has failed or that their job can't start due to budget. Once the budget issue is resolved, users' jobs move into the queue, they're executed on EC2, and once again, they can perform post-processing within the DCV-based environment. Lastly, we'll use an example of the durability team here. As they move through the check to have their job submitted, their job start, they get a notification via email. Once their job is finished, the same notification is available. And once again, they're able to do post-processing and analysis within DCV. As I mentioned earlier, the team has chosen to implement the Elasticsearch service that provides broad capability around analytics into the administrators of the cluster, plus the team leads and other folks will be using the cluster in the future to understand consumption around EC2 resources, storage through Amazon FSx and EFS, and even can be implemented to do things like analyzing license consumption in the cluster. As Madhavi covered earlier, part of the challenge with operating a modern R&D environment is making sure that the environment stays up and running. This becomes even more critical when we're talking about delivering products to market very quickly, as is the challenge for Rivian and other manufacturers. As part of implementing a research and development environment based on open source tooling, it's really important that we have a collaborative support model in place to make sure that no business continuity issues will arise that would affect productivity of the engineering teams, as was seen, as shared in Madhavi's example. So what we did is we worked closely with Rivian and a third-party support provider to implement a full stack all the way from the applications themselves down to the underlying AWS services. And in the middle, you see the open source framework. We set up a collaborative support engagement between third-party Rivian IT and AWS support, enterprise support, to make sure that all elements were covered, including things like cluster analytics, the cloud workstations that I described earlier, all the scripting that's implemented, and of course, the underlying services like EC2, FSX, and EFS.
So where are we today? As leaders, we really like to see the numbers and the progress we have made in terms of scorecard. So we have 3 examples here to share. From OpenFOAM, from Elements company, we use something called OpenFOAM, and we are seeing about 56% speed up improvement in that particular area. From Siemens, we use something called Star CCM. We use many software titles from them. On this particular one, compared to our previous architecture, we are seeing about 35% improvement. And from ANSYS, we have quite a few titles, but the LS Dyna is a big deal, and we are seeing about 20% improvement. And if we see the attestation from the leaders, this data is absolutely proving that this is the way to go. And people who are skeptical about doing high performance compute on cloud environments, obviously the proof is in the pudding after they saw the results. They are more open-minded now than before to consider alternatives, and this is driving some acceleration of adoption across the board. So along the way, actually, our teams have worked really hard, and here are a few lessons learned I want to share with you today. In this particular environment, it is not that actually we knew exactly what to do. We had to go find what would work for Rivian to solve the problem of providing high-performance compute in a reasonably shortest possible time. So we had to learn, we had to fail fast and then succeed. So you saw how many instance types actually we had to try before finding out what would work for our architecture. So we had to have open minds for that, and our teams were great at that. There were some features like AWS Interconnect and the simulation software vendors are all not actually capable of using some of these features. So to really benefit from these features, the engagement from the vendors and how we partner in the ecosystem is a big theme. So having the right people at the table, we were so fortunate that our engineering simulation team actually partnered with us and the different vendors to bring that to life for us here. Obviously, when we are putting in new architectures, we want to make it as seamless as possible for engineers to use. The frictionless is a constant, is a part of our IT strategy here, and connecting with having a common single sign-on, connecting with our enterprise systems like Active Directory is a big deal, and it does take time. So please plan for that if you intend to integrate the architecture into your broader enterprise architecture. Also, this particular area is an interesting one in that it requires a combination skill sets. The skill sets on high performance compute and how it's evolving, the details on the AWS platform and the stack. It involves actually understanding simulation software and simulation world, because I call it that they play Minecraft all day long with beautiful pictures. Obviously, there is a lot of technology and insights behind that. So that knowledge and context of the software is extremely important, and also the basic operations and the behind the scenes, how to make it work day in and day out. This combination skill set isn't as widely available in the industry. So basically figuring out the trusted partners, and we actually have partners like XISS that we rely on for this area. So bringing our software vendors, AWS, our third-party support partners has been crucial in this journey to achieve some of the successes we have so far. And obviously, with the examples I said, it would not have been possible without collaborative engagement across so many different stakeholders. Even within the company, simulation is not like one team. We do vehicle level simulations, we do subsystem level simulations, and we do component level simulations, driving kind of like engagement across, and also at the leadership level has been one of the key lessons learned and success factors for us. So what are the next steps? It's not all rosy. We are not in the final stages of ultimately where we want to be. We made significant progress. We have significant incremental workloads that we will be planning to onboard in the upcoming months as our product roadmap actually unveils and we start to work on multiple programs. Some of the automation around features like using SNS and SES for notifications, obviously as part of the architecture, proactively telling them when their jobs are done or they're waiting on them or something is happening, looking at options to automate some more is in the horizon. And obviously in the HPC simulation world, there is a lot of data crunching that happens, and then there is a post-processing and visualization of results. Hey, the part that I designed, how did it perform under some stresses and strains or whatever tests I made on them, and what am I actually deriving out of it? How do we kind of like seamlessly enable post-processing of the data and improve visualization through newer techniques? That is one element for us to work on. And interestingly, we have another use case, maybe some other time we can talk about it. We are one of the largest installations of Dassault software. We put our product lifecycle management software where engineers create designs and manage part data in AWS. And obviously, after you create designs and create part information out of it, you send those designs or elements of those parts for simulation testing. So integrating seamlessly from our design engineering teams into simulation engineering teams is also something we have on the horizon. So there is exciting work ahead, and we look forward to continued partnership with you to make us one of the showcase customers and continue to be so. Thank you.